Hello everyone and welcome back to our channel. In this video we'll be talking more on triangles. So exterior angles of a triangle, sum of angles in a triangle, and sum of angles on a straight line. So let's go straight into it. For our first one, we have sum of angles in a triangle, and this is a rule we should always recall or remember because it's quite important when dealing with Euclidean geometry. So sum of angles in a triangle always add up to 180. So all angles in a triangle always add up to 180 degrees. So all angles in a triangle always add up to 180 degrees. And so this is what we mean. We mean if we have triangle ABC as shown in the figure below, then angle A plus angle B plus angle X, so I mean angle A plus angle B or beta plus angle X should always give us 180 degrees. That is what the rule means. Then let's look at our next rule or property of triangles. Exterior angles of a triangle. In exterior angles of a triangle, the two opposite interior angles, which is angle A and angle B, are always equal to the one exterior angle. So in writing, this would be written as A plus B, so angle A plus B is equal to angle D. Why? And our reason is always going to be exterior angles of or angle of a triangle. Angle of a triangle. That's always our reason when we use exterior angles of a triangle as a reason. So the two opposite interior angles added together give us the angle D. We are going to do a lot more exercises in this same video just to practice these concepts and try to get them in our heads. Then the third one is sum of angles in a triangle. If you recall from my previous video, I introduced the rule that all angles on a straight line always add up to 180. So these angles on this straight line always add up to 180 degrees. So if they add up to 180 and I take a line and I divide, or lines and I divide this angle into multiple lines, it's still going to be equal to 180. It's just I divided them into a lot of angles. So this angle now plus this angle plus that angle plus that angle plus that angle should give us 180 degrees. We did not change the value of the whole angle, we just divided that whole angle into different sections or different parts. So the angle now consists of multiple angles, and when they are added together they give us 180 degrees. So if I am to write this down using our straight lines or our straight line, let's label it A, capital B, C, D, and E. So if we were to write the total of our angles on our straight line AB, it would be angle A plus angle B plus angle C, and this equals to 180 degrees. Now let's look at some examples that are going to help us understand these concepts better and for practice. So the first question we have that solve for the unknowns, and in this case our unknowns is the theta and the beta. So if we were to write down the answers, we do the following. So the one that's easier here is looking for our theta, then find beta using exterior angles, because if we were to use exterior angles of a triangle, this theta, which is an unknown, plus 80 degrees should give us beta, and that will make sense. So let me write it down in words. So 80 plus theta, I'm just going to say T for theta, is equals to beta. So B for beta. And we can see that we have two unknowns and this equation won't be solvable. So we can't use exterior angles at first because we don't have enough information. So the easiest thing to do here is to get theta by using sum of angles in a triangle. So theta plus 70 plus 80 degrees is equals to 180 and always will, because sum of angles in a triangle. So let's write that down. Sum of angles in a triangle always add up to 180 degrees. Then we solve for t. So t stays this side and we say 180 minus 80 is 100 minus 70 is 30. So our t is 30 degrees, or our theta is 30 degrees. So let us substitute that in our sketch. So 30 degrees. And we've just talked on exterior angles of a triangle. So the two opposite interior angles are added together are equals to beta. So this theta that we just found, which is 30 degrees plus 80, should always give us beta. So let's write that down. 80 plus 30 is always equals to beta. Why? Exterior angles of a triangle. So if we, B is already a subject of the formula, so if we add 80 plus 30, it should give us, so for our B, we have the answer to be 110 degrees. And so that's how you do this question. So you first look for the easier way or part to do first or work out first, and then you work from there. So this would be our answer. So theta is 30 degrees and beta would be 110 degrees. And this makes sense because we've just also introduced angles on a straight line. So if we look at a straight line B, D, and especially at the C part, C, at that part it's still a straight line, and we know that on a straight line angles add up to 180. So this whole angle here, this whole angle means a different color so you can see. This whole angle here should give us 180 degrees because it's angles on a straight line. And we've worked out 110 degrees right there. And 110 degrees plus 70 gives us 180 degrees. So that makes it correct because angles on a straight line always add up to 180. And if you don't know what we're talking about this section here. We say that angles on a straight line add up to 180, and we have 70 plus 110 is equals to 180 degrees. And if we look on the other side, we have 30 plus 80 gives us 110. So we are correct. Let's move on to the next question. Solve for y2 or the y2. The y2 is right there. So let's solve for it. And looking at this, we can see that we can make use of exterior angles of a straight line. But for exterior angles of a straight line, the two opposite interior angles, which is x and 70 degrees, but we should use those for exterior angles of a triangle. But we can see that x is unknown, so we need to get x first before we can get y2. So how do you get x? And we look at the triangle x is in, and we can see that the triangle x is in is an isosceles triangle. And what does an isosceles triangle mean? So let me just draw a small sketch there so that we can just recall on what isosceles triangle means. So if an isosceles triangle is there, that means two lines are equal, and therefore two angles are also equal to each other. So in this case, if this is 70, then that is also 70 degrees. Then that is also 70 degrees. And if this is 70 and that is 70, so let's write it down. We need to practice writing it down also, not just saying it in words. So if we say 70, so the 70 in yellow, so let me just do that. 70 plus 70 plus x should always give us 180 degrees. Y, sum of angles in a straight line. Then we can see that 70 plus 70 is 140 plus x is equals to 180 degrees. And if we make x subject of a formula, we get that 180 minus 140 is equals to 40 degrees. So that's our answer for x, 40 degrees. So let's fill it in our sketch, the different colors. So 40 degrees. And we also know that 40, this x that we just found, which is 40 degrees plus 70 degrees, should always give us y2, y angles on a straight line, not angles on a straight line, but exterior angles of a triangle. So let's write that down. So that 40 degrees we just got, so it's 40 plus 70 degrees is equals to y2. And if we make y2 subject of the formula, we get that 40 plus 70 is equals to 110. And let's move on to the next question. We have solve for A. Looking at this, we can see we don't have much information, but if we look closer, we do, because we have lines that are marked equal. And if you recall, a triangle that has two equal sides is called an isosceles triangle. And if a triangle has two equal sides, that means the two opposite angles are equal to each other, meaning this is just the triangle but upside down. So this angle here should be equal to that angle there. So let's mark it accordingly using the same letter A. Then let's solve for A using sum of angles in a triangle. So A plus 120 is equals to 110. Y, angles, sum of angles in a triangle. So let's just write that down. Sum of angles in a triangle. And so we can see that A plus A is like terms. So 2A is equals to 110 minus 120 is equals to 60. So we have that A is equals to 30 degrees. So let's put it just there. And so we have that A is equals to 30 degrees. And if we double check, we can see that 120 plus 30 is 150 plus another 30 is 180. So let's just fill that in. So 30 degrees, 30 degrees. Everything is degrees because it's angles. Then we have the next question. What is the value of all of these angles? Or what is the value of all of the angles? Let's write that down. Looking at this, we can see that we cannot even use exterior angles. We cannot use angles in a straight line. So all we have is sum of angles in a triangle. So we basically have to solve for x and go on and substitute that x into our angles to get the value of each angle. So angle I, J, and H. So we are going to do the following. So we're going to add all the angles together. So we're going to start with angle J, which is 3x plus 10 plus angle H, which is x plus 5 plus angle I, which is 2x minus 15. And it's all going to be equals to 180. Y, sum of angles in a triangle. Then we solve for x. So we put x's on one side, which I'm going to leave at my left hand side. So 3x plus x is 4, plus 2 is 6. So 6x is equals to, let's just add everything on this side. So 10 plus 5 is 15, minus 15 is 0. So plus 0 is equals to 180. And we have that 6x is equals to 180. So 6x is equals to 180 degrees. And if we say 180 divided by 6, we get that x is equals to 30. But that's not it. We are not asked to solve for x, but we are asked to give the value of all the angles in triangle I, J, and H. So we now have to take this H that we've just got, and we need to substitute it in all. So we need to substitute it in all the angles. So let's look at angle J. So we're just going to say angle J is equals to 3 times 30 plus 10, which is equals to 100 degrees. Angle H is equals to x, which is 30, plus 5, which is 35 degrees. Then we have angle I equals to, and we substitute x for 30, and we get, so 2 times 30 is 60, minus 15 is 45 degrees. So 45 degrees. And so we are done, but we really need to always check if our answers are correct. So we add all the values we've got. So we've just said that J is 100, and we say that angle H is 35. We also said angle I is 45. 35 and 45. So let's quickly just add them all together to see if we get the correct answer. So 100 plus 45 is 145, plus 35 is equals to 180. That means we are correct, and this sum is done because we have determined the values of all the angles in this triangle. So let's move on to the next question, and this is our last question. We have triangle JSW, and we also have triangle WTV. So let me just highlight that for you guys to see. So we have triangle STW, and we also have triangle TWV. So we also have triangle TWV. And we can see that in triangle TWV, we have an isosceles triangle. So the first thing you should do is to just look at your sketch, say the givens, and fill in the sketch with what you can see. So the sketch in this case, the part TWV, or in the triangle TWV, you can see that it's an isosceles triangle. So if that value is y, then that value is also y. So y, because it's an isosceles triangle. And so let's go on and solve for y, because that's what they want us to solve for. But we can see that we can't really solve for y if we haven't gotten x, because y is right there and we need this angle here to get y. So if we have this angle here, we can get y. And how can we get this angle W1? We can get it by saying 180 minus this value of W, because angles on a straight line. But we also see that that also has an unknown, which is x, and we can't really use it up until we get the value of x. Or we can get W1 by using exterior angles of a triangle. So this t value plus angle S will give us W1. So we first have to find our x. So let's solve for x. And looking at this in triangle, I'm going to write in triangle TSW, we have that 10x plus 3x plus 10 plus 2x plus 20 is all equals to 180 degrees. Why? Sum of angles in a triangle. And so if we solve for x, we can add all the stuff on our left. So 10x plus 3x is 13x. So we have 15x on this side, plus 10 plus 20 is 30, is equals to, sorry about that, 15x plus 30 is equals to 180 degrees. And we put the x on one side, so 180 minus 30 is 115, and we have that x is equals to 10 degrees. And if x is equals to 10 degrees, so let's substitute thereafter to get our t, s, and w. So 10 times 10 is 100. 3 times 10 is 30, plus 10 is 40. 2 times 10 is 20. Okay, 2 times 10 is 20, plus 20 is also 40. So they ask us to solve for y. And if we need to solve for y, we can get that one. So let's write it down. To get W1, we can say angle T plus angle S. And that is equals to 100 plus 40, so 100 plus 40 is equals to 140 degrees. So that value right there is 140 degrees. So 140. And if that is 140, then we can solve for y by saying the following. Y in triangle TWV, y plus y, because it's an isosceles triangle, plus 140 degrees is equals to 180. Sum of angles in a triangle. And then we solve for y. So 2y is equals to 180 minus 140, which is 40, and y is equals to 20 degrees. And so y is equals to 20 degrees, and we have solved the problem. What if they had said that we should solve for TW, the length of TW? Because we can see that S is equal to, so S is equal to W in triangle TSW, then that means it's an isosceles triangle, meaning this side here is equals to TW. So it's equals to that side there. Meaning if ST is 13 degrees as given there, then TW will also be 13 centimeters, because we've just proven it. But that was not the question, I was just stating. So that brings us to the end of the video. Thank you guys for watching. See you in our next video as we discuss congruency and similarity. I just wanted to brush off these things before we continued and went further. So thank you guys for watching. See you in our next video. Bye.